Some more problems on solution of triangles. I've done 8th question till now. Now 9, 10, 9 to 15. Let's see. 9th question. SOT, solution of triangles. AC cos B minus BC cos A. I have to prove it equal to A square minus B square. Obviously, if it is coming in terms of squares, I have, and cos is involved, so I must involve cos log. So AC cos B means A square plus C square minus B square upon 2AC. Left hand side. I'm picking up the left hand side. Minus BC cos A means C square plus B square minus A square upon 2 BC. So AC will cancel, BC will cancel. You will get 1 upon 2 A square plus C square minus B square. I took 1 upon 2 common from both the sides, both the terms, and minus is there, minus C square minus B square plus A square. And we'll see what we can cancel. A square cannot be cancelled. C square will be cancelled, and B square will remain. So 1 upon 2, it will be 2A square minus 2B square. So 2 can be taken out common. It will be left A square minus B square upon 2. 2 will cancel. It is A square minus B square. It is equal to A square minus B square. So we had to prove it equal to A square minus B square. It is equal to A square minus B square. Now let us see question number 10. Let us see question number 10 and sort it out. In question number 10 I have sine A minus B. This kind of question we have done just before this somewhere, I remember. Sine A plus B is equal to A square minus B square upon C square. So what we are going to do is sine A, left hand side, sine A cos B minus cos A sin B upon sin A cos B plus cos A sin B. Sin A and sin B will be replaced by KA, AK and AB. It will be AK. Cos B is A square plus C square minus B square upon 2AC. Similarly, sin B is BK and cos A is B square plus C square minus A square upon 2BC. And sin A is AK again, and the same thing because it is A square plus C square minus B square upon 2AC minus BK into, it is plus BK into B square plus C square minus A square upon 2BC. K will cut from numerator and denominator. A will cancel with A here. B will cancel with B here. A will cancel with A here. And B will cancel with here. So as I had told you earlier, K upon 2C is common in the numerator. Because 2C is left here, 2C is left here. You are left with A square plus C square minus B square minus B square minus C square plus A square upon, again K upon 2C will be common in the denominator, and that will cancel with numerator. K is there, 2C is here, K is there, 2C is there. Sin B minus C, A sin B minus sin C plus B sin C minus sin A plus C sine A minus sine B. I have to prove it equal to 0. We have to prove it equal to 0. Again I have A, I'll write it as K sine A. A can be replaced by K sine A. This is sine B minus sine C plus K sine B sine C minus sine A plus K sine C sine A minus sine B is equal to 0. We have to prove it equal to 0. We have to prove it equal to 0. Now K is common everywhere. K is common. Let us multiply sine A into sine B, sine A into sine B, sine A into sine C, plus sine B into sine C and sine B into sine A, plus sine C into sine A minus sine C into sine B. Now when you will realize sine A sine B, sine A sine B with a negative sign, sine A sine C, sine A sine C with the opposite sign, so this will cancel, and obviously sine B sine C sine B sine C will cancel, so you will get K into 0, that will be equal to 0. This is question number 11. We just changed A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to K. I told you we can write also sine A upon A is equal to sine B upon B is equal to sine C upon C is equal to K also. So whatever suits you. Here I wanted the value of A, so I wrote A upon sine A, B upon sine B, C upon sine C is equal to K. So A became K sine A. A became K sine A, K into sine A. B became K sine B. C became K sine C. And then we multiplied them, took out the K common, multiplied everything inside, and all the terms cancelled out with each other finally. So this was question number 11. Now let us see question number 12. A cos A plus B plus C minus B cos B plus A minus C cos A plus B. I have to A plus C equals A plus C, so it will become 180 minus B. Now A cos pi is minus 1, cos 0 is 1, cos pi will be minus 1, so it will become minus A. This is minus B cos 180 minus theta. Cos 180 minus theta will be minus cos theta. Is minus cos theta. So cos C, and it will become cos B. C cos B. This is minus A. This is plus A. This whole thing is plus A. Why? This is projection formula. A is B cos C plus C cos B. So this is minus A plus A, and it will become equal to 0. It will become equal to 0. In question number 13, I have A into cos B minus cos C is equal to 2B minus C into cos square half A. In these kind of questions, whatever, in the next question also, what we are going to do is, we are going to like it is B minus C and this is A. So I'll start with B minus C upon A. It is b minus c here upon a. If I take it to that side, it will become upon a. I can take it to this side. I can write it as cos b minus cos c is equal to 2b minus c upon a into cos square half a. I'll start the question with this. B minus c upon a. B minus c upon a. I can write it as k sine b minus k sine c upon k sine a. K sine b minus k sine c upon k sine a. K will cancel. I'll get sine b minus sine c upon sine a. This is sine c minus sine d. This is sine c minus sine d. Let us apply the formula of sine c minus sine d, which is 2 cos b plus c upon 2 upon into sine b minus c upon 2. This is sine a. I can write it as 2 sine a by 2 cos a by 2. Sine 2a was 2 sine a cos a. If it was sine 2a, it used to be 2 sine a cos a. If it is sine a, obviously it will become half. 2 sine a by 2 cos a by 2, this will cancel. Now, cos, this can be written as pi by 2 minus a by 2. A plus b plus c is 180, so a by 2 plus b by 2 plus c by 2 is 90, and obviously b plus c by 2 will be pi by 2 minus a by 2. It is sine b minus c upon 2 upon 2 is not there, sine a by 2 and cos a by 2. Now cos pi by 2 minus theta, cos 90 minus theta is sine theta, it will become sine a by 2, so this will cancel with this sine a by 2. What am I left with? Sine b minus c by 2 upon cos a upon 2. But I need cos square half a. So what I'll do is I'll multiply it with cos a by 2 here and sine b minus c upon 2, and it will become cos square a by 2, because I multiplied cos a by 2 in the numerator as well as I multiplied in the denominator also by cos a by 2. So cos a by 2 into cos a by 2 became cos square a upon 2, and here it became cos a upon 2 into sine b minus c upon 2. This can be written as cos pi by 2 minus b by 2 plus c by 2. Cos a by 2 can be written as cos pi by 2 minus b by 2 plus c by 2, because a by 2 plus b by 2 plus c by 2 is pi by 2. So in place of a by 2 I can replace it like this, and it became sine b minus c upon 2 upon cos square a upon 2. Now cos pi by 2 minus theta will become sine theta. It will become sine theta. It will become sine theta. It will become sine theta. Cos b plus c cos b, it's okay. It will become sine b plus c upon 2 sine b minus c upon 2 upon cos square a upon 2. Now what will happen is that this is sine c plus d upon 2 sine c minus d upon 2, sine c upon c minus d upon 2. Actually, cos c minus cos d, cos c minus cos d is equal to this. So let us multiply it by 2. 2 sine b plus c upon 2 and sine b minus c upon 2 upon 2 cos square a upon 2. It will become what? It will become cos c minus cos b. It will become cos c minus cos B or cos B minus cos C. Cos B minus cos C. Cos B plus cos C should have been that. Cos B minus cos C. It should be cos C minus cos B. It will become cos C minus cos B. Cos C minus cos B upon 2 cos square A upon 2 cos C minus cos B. Now let us cross multiply. It was like A upon B minus C. B minus C upon A. B minus C upon A was equal to what? Cos C minus cos B upon cos square A upon 2. When we cross multiply, we'll get A into cos C minus cos B minus cos C. Cos C minus cos B and B minus C into cos square A should be cos B minus cos C, not cos C minus cos B. Why it is getting cos C minus cos B here? Cos C minus cos B. A into cos C minus cos B. It is cos C minus cos B. It is cos C minus cos B. I have copied it from. It's cos C minus cos B. So you will get A into cos C minus cos B, B minus C into cos square A upon 2. We get the complete thing. Now let us do question number 14 and 15. The next question is A sine half B minus C is equal to B minus C upon cos half A. It's something similar to the previous question, and we told you how are we going to do it. I'm going to solve B minus C upon A. B minus C is here, and if you take A there, it will become B minus C upon A. I'll solve B minus C upon A and try to achieve this from that. B minus, it will be K sine B minus K sine C upon K sine A. Now K will cancel, you will get sine B minus sine C upon sine A. K will cancel from numerator and denominator, and we get sine C minus sine D again, sine C minus sine D. So 2 cos B plus C upon 2 sine B minus C upon 2 upon 2 sine half A and cos sine A by 2 cos A by 2. Again the same formula will cancel with here, and we will have cos pi by 2 minus A by 2 here, and sine B minus C upon 2. This is sine A upon 2 and cos A upon 2. Now the sine cos pi by 2 minus theta, cos pi by 2 minus theta is sine theta, which will cancel with this sine, and this is B minus C upon A. When we cross multiply, what will we get? A into sine B minus C upon 2, A into sine B minus C upon 2 is equal to B minus C cos A by 2. That is what we were supposed to get as the final answer. So in most of the question where B minus C, whether this was this question and I've done somewhere else also, we do here also, we'll do the same thing here as well in the next question, in the 15th question, which will be the last question for today in solution of triangles. We have A sine A upon 2 plus B is equal to B plus C into sine A upon 2. Again the same question, B upon C, B plus C upon A, I'll solve and try and get this b plus c upon a will be k sine b plus k sine c upon k sine a. It will become sine b plus sine c upon sine a. Upon sine a. Now sine c plus sine d. 2 sine c plus d upon 2 cos c minus d upon 2. So it will be 2 sine b plus c upon 2 cos b minus c upon 2. Sine b plus c upon 2 cos b minus c upon 2 upon 2 sine a by 2 cos a by 2. This 2 will cancel. And let us see this sine b plus c upon 2. It will become sine pi by 2 minus a by 2 cos b minus c upon 2 upon sine a upon 2 and cos a upon 2. Cos a upon 2. Now what will happen is, this will become cos a by 2, so this will cancel by cos a by 2. I have got sine a by 2, which I will get b plus c. Now I have to see cos b minus c upon 2. Now we know what is left, b plus c upon a is equal to cos b by 2 minus c by 2 upon sine a by 2. We know that a by 2 plus b by 2 plus c by 2 is equal to pi by 2. Please look into your question. You have a by 2 plus b, that means you don't have c. So I should remove this c by 2 from here. C by 2 will become pi by 2 minus a by 2 minus b by 2. And since it is minus c by 2, so minus c by 2 will become minus pi by 2 plus a by 2 plus b by 2. It will become like that. In place of minus c by 2, I'll write this. So it will become cos b by 2 minus pi by 2 plus a by 2 plus b by 2 upon sine a by 2. Now b by 2 plus b by 2 will become b, which I am getting here. It will be minus pi by 2 plus a by 2. So it will become cos minus pi by 2 plus a by 2 plus b. If I take minus sign common, it will become cos pi by 2 minus a by 2 plus b. Cos minus theta is cos theta only. So minus theta will become plus theta and it will become sine b plus a upon 2 upon sine a upon 2. When you cross multiply, you will get b plus c sine a by 2, b plus c sine a by 2, and you will multiply a into sine b plus a by 2 or a by 2 plus b. That will finish you this thing.